Good day, viewers. This is Tutor Joshua. Today we're looking at balancing of chemical equation. Balancing of chemical equation is just the act of ensuring that the number of atoms at the right-hand side they are exactly the same as the number of atoms at the product side. In this method, we are trying to obey the law of conservation of mass that states that during chemical reaction, matter can neither be created nor destroyed, although they can change from one form to another. It simply means that the number of atoms, if you have 50 grams of an element in the reactant, they must be exactly the same. The masses must be conserved during chemical reaction. In the balancing of chemical equation, there are two major ways of doing that. The first one is trial and error method, and the second one is by simultaneous equation method. Each of them have their advantages and disadvantages. In the course of our class today, we only be considering the first method, which is trial and error method. So in this method, is a process of balancing by trying many possible ways until we find solution. We can add to the reactant and confirm we do the same thing to the product side until the balancing is done. So let's consider this example. Let's say you can balance this method. This reaction by trial and error method. The first one we want to consider is the reaction of magnesium with oxygen gas to give us magnesium oxide. Looking at this reaction, we can see that it's not balanced. We have one atom of magnesium at the reactant side, and we have one magnesium atom on the product side. That one is balanced, but considering the oxygen has two atoms at the reactant side, where we have one at the product side. So we have to look for a way of balancing it by trial and error method. When we are balancing chemical equation, we must ensure that we did not change anything. We did not change the chemical formula of any of the participants. For instance, this O2 now, this two here, we can't cancel it. Once we do that, we have changed the nature of that compound. So we have to be very careful when we are balancing. So looking at this example now, we can see that since we have two oxygen atoms here and we have one oxygen atom here, if I want to balance this one by trial and error method, if I had two here, in order to ensure that you have two oxygen atoms here now, that means oxygen is now balanced. But remember, in doing that, the magnesium is now two here, and we have one magnesium here. So for me to balance it, I can also add two to this one. So looking at this now, we see that the reaction is already balanced. We have two magnesium atoms here, that's two times one here, and we have two oxygen atoms here, so we have two. Looking at this product side, we have two magnesium and two oxygen. These two multiplies everything here. The second example we'll be looking at is the thermal decomposition of KClO3 to give us KCl plus O2. The first step is to confirm if the number of atoms at this side they are exactly the same with the ones here. We have one potassium atom here, that's 1K. Then we have K here, 1K also. That one is balanced. And chlorine also, we have 1, but the oxygen are not the same. We have three oxygen atoms here, and we have two oxygen atoms in this place. So how do we balance it? So looking at this now, since I can't remove this two here, and I can't remove this three here. So what do? If I multiply this O2 times 3, that is if 3 is placed here, that means you have 3 times 2, that's 6 oxygen atom. And in this place, I have 3 oxygen atom. If I multiply it times 2, that means oxygen is now balanced. We have 2 times 3 for the oxygen, and we have 6 atoms of oxygen, and we have 6 oxygen atom here. That means oxygen is balanced. But remember, the K and the Cl has been affected. We have 2K, that's 2 times 1 potassium, K here. We have 2K here, and we have 2Cl here. But looking at the product side, we have 1K and 1Cl. So for me to balance the K and the Cl now, I simply add 2 with this. So let's now confirm if it is balanced or not. We have two. Looking at this now, you can see that the number of atoms, either for K, for Cl, or for oxygen, they are exactly the same as in this case. So we can see that this is balanced.